She goes, well, that was a picture that reminded me of my grandma.
Now that's been recorded, so I hope you know. That's saved forever.
That's
Okay, sinusoidal functions. Sinusoidal just means it is a sine-like function. There is a lot of natural phenomena that behaves like a sine function. Those are two. It comes in a bag. It's probably bad for you. Yeah, one Pop-Tart is 19 grams of sugar, and there's 2 in here. That's right.
So that's 38.
Yes. Look at you.
Oh my gosh, you didn't know
Way more sugar than anyone
That's
should
what
eat.
I'm
Okay, so sinusoidal functions can model a lot of things in the real world, which is where they come in handy to scientists and whoever it is. When I was in a stats class in college, we were forced to use this with temperature, and they were talking about whether or not global warming or climate change is a thing. What you basically had to do was figure out if the midline of your sine function was increasing or not. We can do a similar thing with tides, with rainfall, with temperature, sound waves, animal population, blood pressure. All of those can be modeled with a sine function. Hello? I do. Sounds good. Thank you. Bye, Kyle.
We're recording it.
Just for you.
Yeah.
Before there was a hint. Now this is a more direct hint. You shouldn't do that.
Wait,
Yeah.
do I have to write that down?
You have to
Do I have
listen
to
to
know
the
that?
edges here. Okay, so we're going to talk about we're going to do examples of a few different ones of these.
How do rainfall involve math?
Because you can model it. Certain periods of time might have more rainfall or... Hi, Miss Feminine. Yes, she is. She said no, she's wrong. Guys, it's a health book that she wants to give you. Because we were just discussing how many grams of sugar in one Pop-Tart?
19. Oh my god, Pop-Tarts are...
I found a box of Pop-Tarts back there. I'm going to throw them away. There's, as Kyle told us that he just left, there's 38 grams in 2. I'm like, no, guys, you're going to...
And it's the nutritional content of cardboard.
Yeah. I'm good.
I think cardboard has
If you were in my class last year,
so
then you
bad for you.
probably know about my hatred towards Pop-Tarts.
I saw them in the corner and I was like, first off,
Think
why
we
are
ever
these back
talked
there?
about
Second off, I'm throwing them away.
Yeah.
No one
Maybe
should.
there's someone like
Yes.
Like, this is good.
I know. That's been my life this year. This sums it up.
Ashley, now I'm gonna purposely pack Pop-Tarts in my little carry-on, take up like a whole.
So many. I kind of just want to like frame it.
Sleep it there.
Maybe put it on my list. Okay, write this down.
4,000.
All of it?
4,100? You impressed me. Good job. So, all of our word problems are going to be about those different types of natural phenomena. Making sure. There's still 2 in here. No, I'm not really hungry. We already discussed why not. What's the problem? Not for sugar.
You see this?
Right.
This is all 2 Pop-Tarts a day.
Okay, so this one is talking about the tide and how often it peaks, because with our, moving around the moon, our tides go up and down, and they do that in a sinusoidal function. This is part of like what scientists can use to figure out if the tides are receding or not, or what's happening. Okay, good attitude. Write it down anyways. If I remembered, I would try to remember. Yeah. You're welcome. What I will tell you with all these, I'm always going to recommend you sketch it. So once you write it, the first thing I'm gonna do is based on that information, try to fill in a rough sketch of what's happening. Whose cans are those?
Those Maddie's?
Hmm?
Are they Maddie's?
No, I put those away.
Oh, well, I don't know.
Oh wait, were you, is your Maddie?
There's multiple Maddie's in here.
I know.
Not as many as last year.
It's true. It's a win.
Yeah, Osmer was complaining that she had 2 Maddies in her class.
You respond.
And I said, are you serious?
Okay, where can we start to fill in some of this info?
Midline,
Midline is what?
3.6.
Good, I don't see 3.6 there. Where'd you get it from? You're right.
I mean.
If you do 3.9.
3.9.
Good, you know your max is 3.9, you know your min is 3.3. Halfway between has to be your midline. Okay, where else can we put things?
It's a negative cosine.
Where t equals 0, so your x, t equals x, and then you can infer that it's going to start at 3.3 because low tide is low.
Good, and I know low tide's here. Then after a minimum, where do I always go? 0. And then up to your max. 0. Min.
And you have that part of that may represent 24 hours.
Good.
Not quite.
Well, not high it's like.
A little less.
Wait, is this like our added one?
Hmm?
Separate document?
No, we're not. We don't have a
I
shift.
mean, if t.
So this is your graph. How do I figure out how often this is?
Well, the peak is 11.6, so that's here.
It will peak every 11.6. So it takes 11.6 hours to go through a full cycle for this
I
function.
feel like I'm going to, but I feel like.
What does that mean? Where does the 11.6 go? So the answers I've heard is it either goes here or here. Which one's
Where
correct?
are we
The
starting?
middle.
The peak. I mean, it's at the end if we're starting
It's a
at
full
0.
cycle, so it goes at the end. Wait, what?
It peaks every 11.6 hours, which means it takes 11.6 hours to get from peak to peak. Doesn't that also work from low to low? Isn't the period the same no matter what? Okay, so it takes 11.6 hours to do a full cycle, which means that is 11.6. My period is 11.6. To write an equation, do I care about what all 4 tick marks are or just the full period? Yeah, so I can just leave it at that. You can find me all 4 if you want, doing exactly what we've done before. Cut it in half, do the 4th, do the 3/4. But to write an equation, I just need this. What's my amplitude?
1.3.
Is it positive or negative?
Negative.
Sine or cosine?
Cosine.
Do we agree with all of that so far?
You wrote it down, so yeah.
Make sure we agree with that besides that. Where did we get our 0.3 from?
3.9.
Yeah, how far apart these are or these are, whichever you prefer. It is negative because it started at a minimum. It's cosine because it started at a minimum. What's my period?
Theta over 11.6.
My period
Oh, your period is 11.6.
is 11.6. So the 11.6 equals 2 pi over k, yes? So what's k? Flip it, because this goes bottom, right? Can you cross multiply? And I'll be nice and let you leave it at that. Does it shift? Or is that where I expect a cosine graph to start? That's right, yeah. So there's no shift. What's your vertical shift? 3.6. There was no horizontal, because that is what I expect a cosine graph to do. But there was a vertical. Questions on that? I know what the Snapchat start screen looks like. Can I change it? Write that down. Okay, you guys know much more about blood pressure than I do, especially if you're an MI. Or the related ones. Or you just know more medical things, but I can change your trade part of it. Or from personal. It's okay.
Do you have high blood pressure, is it?
Yes.
Are you an MI?
No.
Oh, you just know that too. Good job. I can just find from every other science class. That's a fairly low level medical thing, but probably, yeah. We'll ask our girls later. I know.
Don't ask her that.
Don't ask her that word.
Just because I don't know what's happening in it doesn't mean that she doesn't know that I know what's happening.
Got it.
Just be like, hey, did you know Sarah doesn't know what's going on?
Now I
You should
really
explain
want
it
to.
to me.
Now I really want to, so we'll see how that goes.
Well, we were gonna like save bells yesterday, but they were
Okay. Just so you know how blood pressure works in the event you don't know how blood pressure works. Who can explain blood pressure for us?
The top number is when your heart contracts,
Good.
so it's normally higher because you put a pressure on your system.
Correct.
And then bottom one is whenever it expands to let blood back in.
Correct. So every time your heart beats, you oscillate between those two numbers because you're shoving the blood through your body. Otherwise, it would not move if your heart didn't beat, which is why that's a problem. Okay? So your blood pressure oscillates between these two, which means it will look like a sine function. Roughly. Won't be perfect. What can we label?
140 is your maximum.
Cool. What's my midline then?
110.
That's two different numbers. Which one's right? What's halfway between 140 and 80?
Oh,
Number.
Correct its number, and that number is specifically 110, so that's good. Do we know how we got the 110?
Yeah.
You're finding the average, so you can always just add them up,
And divide by 2.
divide by 2. That will give you 110. You have a brain, and I believe in you.
How am I supposed to know what?
14 plus 8 is? And then put a 0 on it? I believe in you.
It's supposed to divide.
Okay, so according to this one, this person's heart is beating how often? Once per second. So it takes 1 second to go through that full process in this example. Do we know when they started measuring it where their blood pressure was? Did they tell us? No, so we get to pick. You don't know, so you get to tell me what you want it to be. What do we want it to be? At the midline, the max, or the min?
Mid.
Midline, that's usually the popular one.
It's easiest to do, so.
Okay, then let's say it went up, and back down, goes up, goes there. So if I don't tell you where it started, you're welcome to just pick where it started. If I did tell you, you would just start it there like we did on the last one. Now do we have enough to write the equation then? Yeah, so y equals, is it positive or negative based on how I have drawn it? Good.
30 positive.
What is my amplitude?
30.
Good. My period was what again?
1.
1. Wait. So what does that mean my k value is? 2 pi. Oh, I didn't write sign. Thank you. I'm sorry. I was like, that looks weird. Oh, because I didn't write it. There we go. Do I have a shift? Or is that what sign should look like? That's what sign should look like. Do I have a vertical shift?
Yes.
Plus what? Good.
Why do you have K when 2 pi is?
Sorry, theta. Thank you.
My goodness, right?
I know. Questions on that? Write that down. If you want to summarize it, do you? If you don't want to summarize it, do you? Write down what you need.
Where's my black? Try to sketch me that graph. What's my midline?
0.
What's my max? Cool, and my min? Perfect. My k is pi over 6, so my period is what? Multiply by 6. Good. It'll be 12 pi over pi, which is 12. This is 12. Since it is a negative cosine graph, where will it start? And good, it'll go up here. Okay, we're going to use that to try to answer these 3 questions. Where is the buoy when time is 0? -5, but this one is nice because you can just look at that. It is at -5. What is your max height of the buoy? 5. Did you even need the graph for that part?
No.
No, you could have just used your midline and your amplitude and found that. How do I figure out the height when t is 9? Look at gonna do this, and I've heard both correct answers, which is good. One thing is technically, you're just plugging in the 9, and we're gonna have to do that in a minute. But you can absolutely do that here and do pi over 6 times 9 and evaluate this. Okay, you don't have to do that here. And what Logan and Zeke noticed is that 9 is actually one of these tick marks. Okay, so half of 9 is 6. That would be this one. A fourth of it is 3. And 3/4, sorry, 12, not 9. 3/4 of 12 is 9. So I know that strictly from the graph. You can do it either way. Regardless, what should my answer be for the height of the buoy? 0. So you can either pull it from the graph or from evaluating it. The next one we're going to do, we're going to be forced to evaluate, so I will show you specifically how to do that. Yes, sir?
We're gonna have to do the addition subtraction identity thing.
You won't have to now,
Okay.
because that'll simplify and give you a nice pretty number.
Always?
When I'm going to give it to you, yes.
Okay.
In
So I didn't mean
real
like
world,
in this scenario, but like,
when I give it to you, it'll be nice.
okay.
This scenario is
So not yet, is what you're saying.
Because it won't always be like that.
No, it won't pop out.
5 feet of water.
5 feet.
Maybe it's 6 inches. You don't know what this
Still
is.
won't.
Okay, write
Maybe
this
it's
one
an
down.
ocean. It's just really
They
wavy.
pop.
World waving water. A speedboat just went by. It's going with the water. The water's just going straight down.
Okay.
Yeah, it's not bobbing out with the
Foundation's
water.
like on the hook.
So, write this one down.
Always going by?
Yes.
And like a buoy is like,
Constantly
put out
on.
like in the water.
I want to know.
Write this down. There's gonna be a lot of water.
It's fine, I have one of my.
Good. Try to graph this even as you did yesterday. You were first and Zeke's first. I don't put no sugar, no others.
What?
They were first. They can share, but they were first. I don't recommend eating 38 grams of sugar, so like I do recommend sharing.
Jacob, you want one? I don't like Pop-Tarts.
Jacob and I are on the same page.
Pop-Tarts are like, it's too sweet. It's gross.
I disagree. Zeke, you go.
It depends. I mean, it really just depends on the pop.
So make sure that you are doing this.
It's really giving me a pop.
green is my math behind the phase shift. So remember, you do negative c over k. So c becomes positive pi over 2. K is pi over 6. Multiply by 6 and you get 3 pi over pi, which just gives you 3. Am I moving to the left or the right? Good. And is that an increment I can just count on the tick marks with? Yeah. So I'm going to move it over. This one will go here. This one will go here. I don't want to add to my graph. What do I know will be the point on my 0? Will it be at min, max, or midline? Okay. And I will do my best with these to make them context appropriate. So reading this, what it is the daylight hours per day in this city in Texas. What would the 0 and 12 represent? What month would that be? So they're both December. Do we agree December has the shortest days? Yeah, that's when the winter solstice begins. So December has the shortest days. Some of you are looking at me like that's new, and that's okay. December has the shortest days. June has the longest. Is June at my max? Yes. So I will with these try to make it actually accurate. Okay. Then we can go through the amount of daylight when time equals 0. How many hours in the day when t is 0? 10.5. Perfect. What's the minimum amount of daylight? Amount of daylight in November. Do I have a tick mark that represents November?
11, but it's not there.
Yeah, there is an 11. We could, put it there, but it doesn't give me a pretty value. We agree? It is not 10.5, 12, or 13.5. Agreed? So what we have to do in this case is actually plug it in. So we're going to take our equation, and we are going to plug in 11 for the t. And we are going to be able to evaluate this. And on your test, I will make it sure it is something that you can actually nicely evaluate. I think this one turns out ugly, but on your test, I will make it something pretty, and we'll just talk about how you'll do it. What do you do first here? Parentheses, how do I condense this?
11 pi over 6 minus 3 pi over 6.
Good, you get a common denominator. What's 11 minus 3? 8 over 6, right?
Yes.
Okay, so 8 over 6, does that simplify?
Yes.
To what? 4 pi over 3. Yeah? Now what? Addition comes last. Remember your order of operations.
That's the one.
What can I do next?
That's a 6.
Do this sign.
Good, you need to do sine of 4 pi over 3. That is a 60-degree reference in what quadrant? 3. What is the sine of a 60-degree angle? Opposite of the 60 is?
2 over 3.
Opposite of the 60 is? Square root of 3. Hypotenuse is? 2, and it's negative because it's in quadrant 3. This one turns out ugly on a test. I would make it be pretty for you. I promise. But you will do the exact same thing. Now what can I do? Okay, on a test where you don't have a calculator, that would be your answer. What I want you to do, because you have a calculator, type that into your calculator and make sure it's reasonable based on your graph. Okay, so type that in, evaluate that, tell me what that decimal approximately gives you, so you can make sure it's actually reasonable based on how our function is. But on your test, you would be able to do that math in your head. It would be like a half or a 1 or something instead of the ugly stuff. What does that give you?
3.7.
Okay? Which, looking at this, here's the 11 approximately. Yeah, it's real close to 10.5. Okay? Be able to approximate that and say, yes, this is reasonable, or no, this isn't. You don't get a calculator, so you would just leave it at the green part, or like I said, I'll make it one that you can go all the way through because it's going to be an answer of a half, or 1, or 0, or whatever it is. I will make it be pretty if you have to do this. Questions? Okay, this last problem we are going to do twice. We are going to do once by hand and once by calculator. I'll bring them around in a second. So, at the top, there's a chart. You're all going to go, and groan. Instead of that, just remember you're doing this problem twice, so just write it down once, and then we'll just do it twice. Okay? But there is on your test a no calculator portion, or sorry, the calculator question on your test looks like this. So we will do it once by hand and once by calculator, and there is a question on your test where you have to do this by calculator. When you do this by hand, because it's already complicated enough, is just do your average of your max and your min. So what's my minimum? Cool. What's my maximum?
66.
Cool. This won't be perfect, but for the by hand portion of it, you're good. Because remember here, you wouldn't have a calculator. And I'm not going to make you add all those up and divide by whatever. Okay? What's 41 plus 66?
107.
Good. What's half of 107?
52.5.
Good. So my midline, my vertical shift is 53.5. how far away is 41 from 53.5? You can do whichever one you. How far away are they? 12.5. Good. My period, how long does it take to go through the cycle? How long is a year? Good. 12 months. What I want you to remember is when we put that in our formula, it's not going to show up as the 12. Okay, you will have to find that K value. What will my K be anytime it's a year? Notice that what number always shows up when it's a year?
6.
Yes. Pi over 6. So when you solve this, you get pi over 6. Okay. So then I'm going to start to fill this in. If we sketch it, I'm going to sketch on the board to save some space. It's approximately that.
Wait, why do we need to sketch it when we have all the information?
You don't have to. Sketching is just if you need it. What does that look like? Sine or cosine? It looks like a cosine, yes? Okay, what's my problem with it though? It's negative. That's not a big deal though. I can just make it negative cosine. Is my minimum on the y-axis? What's the value for January? 1. Yes? So my minimum value has a t-value of 1. Remember, your 12 and your 0 are the same, but 12 is not a minimum. That means this has to have a shift. Huh? No, we cannot say it's close enough. Okay? Anytime you have a shift, there's some math you're going to have to do. So we're going to plug in what we do know. You do get to pick whether you want this to be a sine or a cosine. I would pick the one it still looks most similar to here. What does this look the most similar to here? Cosine. So we can make it a negative cosine. It does not matter. Your calculator will always make it be a sine function. Okay? Negative cosine. Sorry, what was my amplitude that I failed to write? Times the cosine of, I know it's pi over 6 x or theta. I'm going to leave my minus c. Sorry, it's plus c in your formula. Plus what? What's my h? No, it's not. It's 53.5. Sorry. I went with it too. I was like, yeah, it seems right. We have a phase shift. So now we have to find it. And this is one way you can do it. When we get to review day, we'll talk about another way too. We need to solve this problem for C. What do I do to start to isolate the C? Or what, sorry, I can't isolate it now because I don't have anything plugged in. How can I plug something in? Plug in 1 for what? Hmm? 41 for your y, right? Okay. I can plug in a point. I would plug in either your max or your min. This is one way to do it. Because I know all of those ordered pairs. I know that when it's 41 degrees, that means that my t is what? Or my theta is what? 1. And I will show you 2 ways to do this one. This is just one way. You could use that, yeah. I'm going to show you both ways because depending on how your brain works, one way might be easier. Okay, we're going to solve this for our C. What do you do to solve this? subtract the 53.5, which is going to give you what? Negative 12.5. That is math you already did, so it should work out. Now what? This should always come out pretty, as long as you use the same thing. It should always come out pretty. Now what do we do? How do I undo the cosine so that the C is kind of free? Yeah. You can do the arc cosine of 1 will equal pi over 6 plus c. How do you get the arc cosine of 1? Your brain. Is that a quadrantal or a special right? Where does cosine equal 1? Where does it equal 1? Yes. Huh?
Okay, yeah. Maybe you really made me down.
That's what I know. It's just you're good. We agree? And now what would you do? What would your C be? And that would go into your equation. I divided it over. Yeah, because it's multiplied, so you have to divide it. You just would have done it. There is a second way to do this. This is the more algebraic way, so if you are an algebra fan, that's probably the way you're going to like. The other way is a little more conceptual. Okay? What you can do, look at this graph. I know my minimum is at 1. For it to be a cosine graph, where do I actually want it to be? Where do our minimums have to be on a cosine graph? 0. So it should have been here, and then it moved to the right 1. Do you agree with me? So my phase shift was 1. Then can I use my formula? So 1 equals negative c over pi over 6. And it will also, in my opinion, easier way, give you negative pi over 6. But you have to understand the graph better for this one. Does that make sense? Either way gets you negative pi over 6. My personal preference is this one, as long as you understand it should have been at 0. It moved to the right 1. Does that make sense? Does at least one of them make sense? That's all I care about. Okay? Your equation here then would be y equals negative 12.5 cosine of pi over 6 theta minus pi over 6 plus 53.5. Either way you do it is fine, whether algebraically like on the board or visually with the graph. That's why I sketched it for you. Either way is perfect, because as we saw, we got the same answer either way. Does not matter which way you do it. Okay, that's done. Yes, that's quite the problem I know. When you have it on your test, it will be the no calculator question. It will ask you to do part of it by hand, and then at the end it will actually ask you to do all of this by hand. Then it will say, okay, use your calculator and do it for me. So you will have to do it both ways, because your calculator will never give you a cosine graph. It will always give you sine, and your calculator will actually be more specific. So what we're going to do is use your calculator to do it now. On Canvas, I have put directions. If you open Canvas, it's called just 6.6 regression on PIs or something, and it has all the steps written out for how you do this. And I'm going to pull it up here as well, but just know that that is on Canvas. I'm going to pull up both of my things up here. The directions, there's one step I'm going to tell you to ignore. Steps on the board. For it to be an actual cosine graph, it should have been 0. My minimum, but my minimum could actually apply. So I took my parent function and I moved it to the right one. Does that make sense? So that that phase shift equal to negative C over K that you already have and go from there. That will get you this answer. This to me is longer, but it's more algebraic. This you have to know, how did I get the 1, and then you can do it from there. If your minimum was better, it moves to the right too. Yeah, exactly. And then I fall on top. This online again gives you all the steps. I have it here. Do not feel like you have to scurry and write all of it down. But we are going to be able to make our calculator do it for us. What you are going to do, you want to hit y equals and just make sure it's blank. I am going to make you reset your calculators before you do this, so it should be blank. Okay, but if it's not blank, make sure it's blank. Then you need to get to your stat plot, because we're going to plot some points, and it's just second y equals, and it should look like this. Everyone got to there? Okay, what you want to make sure, you're going to go into your plot 1, so I'm just going to hit 1 so that it opens that one. You can also hit enter, either is fine. You need it to be on, because if it's not on, you can't do it. So you're going to hit enter when it's on the on, because it will be off if it's been reset. And you also want to make sure that it's these open dots, which again, if it's reset, it will default to that. Okay, your X list should say L1, your Y list should say L2. I think there's a calculator somewhere that for some reason has list 1 deleted completely, and I don't know how to get it back. So if that's yours, we will talk about how to fix that. Or I'll grab you a new calculator. Okay, does everyone have this turned on? We're good to hear. Okay, you're going to go to stat, which I always lose. There it is. Next to your variable button. So you will hit stat, and you need to go in and hit enter because you're going to edit. In this, you are going to enter in all your data. L1 is going to be your months. So you're going to do the numbers 1 through 12. And don't put an extra number. Then you're going to hit the right button. You're going to have your L2. And you're going to type in all the data points that I gave you, so all those months. You do want to make sure that they match up with each other as you're going through it, because otherwise it'll throw off what you're supposed to have. So I'm going to go through and do 41, 44, 47. Again, that all of them are entered in, and they're next to the correct month. So your list should be the same length, should look like that. Questions on that part? Okay. You need to set your window based on the information I gave you. Your window defaults to -10, +10, -10, +10 for X and Y, but that won't help you. Our X's go from what to what? What X values did we type in your first list? 1 to 12. I would always go a little outside of it, so like I'm going to do 0 to 13, just so I make sure I see all of it. What did your Y's value go between? 66 and 41. Again, I give myself a little buffer, just so I make sure I see it. So maybe like 40 to 70 or something. It doesn't matter as long as you can see it. Then hit graph and your dots should show up. Questions on getting to there? Okay, you don't have to go look at it. I just always do to make sure I got it in correctly. If your graph looks super funny, there's going to be a problem. The way you do these actual sine regression is these next steps. So you're going to hit stat again. But this time you don't want to edit anything, you want to calculate. So you need to go to the right to that calc button. And it's going to give you all the ways we can do it. What you have learned in Algebra 1, you did linear regressions, which are when you plotted points and you tried to match a line to that. That was like your line of best fit that you did. We can do that with any function. So what we're going to do is try to match this to a sine function. And if you scroll down a bunch, I think you can even just push up and it's faster. These are all the ones we can do, and you want a sine regression. And you'll hit enter. It does not matter as far as I can tell what the iterations says. List 1 and list 2 should be where your data is at. So it says X list, that should be your 1 through 12. Your Y list should be your months. Then you're just going to hit enter all the way down to calculate. You don't care about any of that. And it's going to give you this. Okay, I'll say it'll think for a second and then go. This is your equation. It's going to tell you, this one needs to be correct, a formula, and then it's going to give you an A, B, C, and D. When you type in your A, B, C, and D, I want you to keep at least 4 decimal places. So this will be like 11.8373. Sine of 0.5543x minus 2.4495 plus 53.3546. It'll keep me 4 decimal places, but it will give you that. I'm going to write down our other equation. What I want you to do if yours gave you that and you're good, go and graph both this one and the one we came up with. So I've written both of them there. Okay, if yours didn't give you this equation, please tell me so I can help you figure out what happened. Okay, so make sure you got that equation. If you need help, please tell me. And then graph both of them for me. So this is where you'll write them down. So like your A gets plugged in, your B gets plugged in. Nope, you just plug it in. Now I'm going to go graph it, so I am going to type mine in. But so that's your answer. Now I'm going to go type it in. I'm going to just now to show you that they really look similar. Because right now my equations are super different than each other. Yeah? And that's what I want you to see, like, how it really is very, very similar to each other.
It is very similar.
And if it helps you, if you want to like graph one at a time, you're more than welcome to. The nice thing is it will keep your data with your graph. And in this case, both graphs. minus negative 2.44 whatever. It should just be minus that. Now it should get a little bit better. Okay, so again, yours should look like this when you're done. The right side of my graph. Do you agree the graphs kind of merge together and look exactly the same? Okay, that's helpful. That tells us our graphs are on point. The other thing to look at here, they're a little different. The one that's kind of on top is the one we did by hand. The one that's on bottom is the one the calculator did. Which one's more accurate? Top or bottom? Bottom. So the one that the calculator did. Does it make sense that the calculator's was a little more specific than ours? Okay, when the calculator did it, it took every point into account, yes? When we did it, we approximated a few things. You could absolutely take more into account and get some more specific numbers here, but that's why theirs worked a little bit better than ours, okay? But they are both fairly accurate in terms of representing what's actually happening here. Questions on how we got any of this? The calculator question on your test will look pretty much exactly like what we just did. It will give you a problem, you will do it by hand, and then you'll ask your calculator to do it for you at the end.
You have to do it by hand first.
So it will be on one piece of paper, but it will ask you to like just calculate all of these things and then go. And then like the last one says, use the sign regression part of your calculator to do blah, 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 blah. Questions? Yeah.
My graph, I just get 2 straight bars.
You have too many parentheses in this section. Well, you don't have the word, oh wait, I'm gonna just clear this completely. Negative 12.5. If you are done on that, you can start your homework. I think at least one of them it will be helpful. There's one that looks very similar to this that I would strongly recommend practicing your calculator skills on. So if you need to, flip in your notes to, or in your homework to that one directly, so that it's easier. You had a lot of parentheses around this last time, so I'm going to put those like one too many somewhere.
So I don't know if it would do it in the right order.
So maybe it's one, so your first one, so that's your first one. So that's your second one. So graph it in order. Yep, that will do it. You have like 7 minutes. Again, I would pick one that is a calculator one if you need more.